Okay, so today's point is about topological sorting. Okay, so this type of diagram, this is a graph, you know very well how to, if you want this graph we can find the matrix also, right? So topological sorting for diagram a cyclic graph. This is, we can say, DAG diagram, DAG, that is a direct diagram, direct acyclic graph, right? So, is a linear ordering of vertices such that for every direct edges UV, okay, vertex U comes before V in the ordering. So, topological sorting for graph is not possible in the graph, is not a DAG. For example, the topological sorting of a following graph, you can see this in this graph 5, right? 5, 4, 3, 5, 4, 3, 1, 0. Okay, a topological sorting of the following graph is 5, 4, 3, 4, 2, 3, 1, 0. There can be more than one topological sorting for a graph. For example, another topological sorting following graph is 4, 5, 2, 3, 1, and 0. The first vertex in topological sorting is always vertex with degree 0. A vertex with no incoming edges, you know, incoming and outgoing edges. If it come like this is the incoming to 5 is incoming edges, right? You can see here it is the outgoing, and this is the income. If arrow is there like this is incoming and it's like this outgoing, you know, we have seen this incoming and outgoing, right? So topological sorting versus depth travels. DF is depth first travels, we print the vertex and then recursive call. DFS for the adjacent matrix. In topological sorting, we need to print vertex before edges. Okay, in DFS we need to print vertex before vertices. For example, in the given graph, the vertex 5 should be printed before 0. Vertex 5 should be printed before 0. But unlike DFS, the vertex 4 should also be printed before vertex 0. So topological sorting is different from DFS. For example, DFS, the graph is a DFS graph 5, 2, 3, 1, 0, 4, but it's not topological sorting. Okay, so single, short path. So here you can say single source short path problem in which we have find shortest path. यहाँ पे हमें shortest find part करना. Okay, we have to find the shortest path from a source vertex V to all other vertices in the graph. The signal destination shortest path problem in which we have to find shortest path from all vertices in the graph, direct graph to single destination vertices. So here input is a weighted direct graph, that is a VE, you know, with the meaning of vertices, edges, right? Then output here and into n matrices shortest path distance. So this is a formula of, right? So we know already how to find with the help of graph. We have seen. If you don't know, then go check my previous lecture. Here I already explained how to find, right? जैसे कि यहाँ पे we have to find watch the incoming and outgoing edges, right? 1 and 1. So here not incoming and outgoing edges, so here we have put 0, then 1 and 2. And so we have to see, right, like this we have to find our edges. Okay, so this is about the single source path, right? Okay, then next, this is the next. Okay, so now we have to see topological sort. We just wait. Okay, so in topological sort, topological sort is an algorithm for directed acyclic graph, right? Topological sorting for direct acyclic graph is a linear ordering of vertices. Such for the direct edges UV vertex U come before V in ordering, right? Topological sorting. So working of topological sort here, initial degree is the compute for all vertices. So you can say here, as a computer degree, suppose V0, okay, V0, example, okay, v1 dot example 0, then v2 that is 1, v3 2, v4 2, v5 2. Okay, so what do you want to do here? Find vertex. Suppose find vertex with in degree 0, that is v1. Okay, insert it in the queue. Okay, let's see then. Okay, so for this we have to draw the diagram, so table here. So let's take table. So we require just 1 minute. Okay, okay, so here we will what we do, find the vertex in degree v1, insert v1, right? We insert the v1 here. Okay, so output here v1 removes. Okay, so in next here v1 remove from the queue and update the in degree remove, that is v1 v2 and v1 v3 and v1 v4. So here what will happen, just 1 minute. v1 remove of in next column here v1 will remove. Okay, v1 remove, we have to remove one by one whatever we'll insert in this. Okay, so v1 remove, then we from the queue and update the in degree remove degree, that is we have to update like v1 v2, then v1 v3, then v1 v4. Okay, update in degree. So to update in degree, after v1 we have to use v2. So we have to remove v1. Okay, so we will remove this so directly v1. Okay, okay, v1 we will remove, then here we have to put v2. Okay, so this is about the shorting topological graph. So shortest part, we have seen that shortest, this is a diagram I already explained previously how to find the number, how to do matrix through this diagram, so I will not explain here again. So just understand that finding the shortest path is one of the basic problem encountered in the many graphs application given graph. So here graph ve and the vertex s we need to find. Okay, so shortest path means that is s is every other vertex in g. So generally there can exist more than one path between a particular pair of vertices. There are different variation of the shortest path problem which vary in the term of specification of the source vertices and destination vertices of a path. Shortest path can be found from one particular source vertex to all other vertices. This is known as a single source shortest path problem. You can say Dijkstra algorithm also. Okay, so shortest path can be found from all possible sources vertices to all other destination vertices. This is known all pair shortest path problem. A single shortest path problem, that is a Dijkstra algorithm. Dijkstra algorithm find the shortest path from source vertices V to all other vertices in the graph. It can also be used to finding the shortest path from a single node to a single destination node. By stopping the algorithm, once the shortest path can, you can say that the shortest path When the shortest path to the destination node has been determined, it works in the directed or undirected graph, and all edges in the graph must have non-negative weight. So graph should not contain any cycle. Okay, graph should not contain any cycle here. So algorithm maintains distance parameter for each vertices of the graph. These distances are initially set to infinite for all vertices except the source vertices. This is done not to imply there is an infinite distance, but to note that vertices have not been visited. Okay, so algorithm involves repeated iteration of the following process. At each iteration, we have a tree rooted. For a first iteration, the tree will be single vertex s, and the distance to will it will be 0. For subsequent iteration, the next vertex v to be added to the tree will be closest unvisited vertex to S. Once we found we add V edges UV and gives the shortest distance for U. Then the one we gave short for U. If yes, then distance of U updated new smaller value. We also maintain for each vertex V a parent vertex which determines the last edges that is used to get to V from S. Okay, so here um, minimal spanning tree we will see now. Okay, so minimal minimal spanning tree. Okay, spanning tree. So let's see the in a connected undirected graph, that is in connected undirected graph, that is equal to g equal to v and e. Okay, so here if we can cover all the way vertices but not all edges also. So no cycle is formed while covering all vertices, then such component of graph is called as a spanning tree. मतलब cycle form नहीं होनी चाहिए. Spanning tree means no cycle should be formed. We can also define a spanning tree, a connected graph G as a subgraph G that contains all vertices. So let's see this diagram of graph. Okay, let me draw first. Okay, so here we can see that is a okay. Let's draw first this then okay. Let's draw this. Just for me. So for this we have to okay. So this is a diagram of your spanning tree. Okay. So okay, we have to connect this all. Okay. So here in spanning tree, no cycle is formed. So this is a simple graph. Okay. This is a graph G. Graph G. Okay. So here, now we want to do spanning tree. So for spanning tree, we will just 1 minute. For span, this is a spanning tree. Okay. So we know we don't want cycle form. Okay, in our graph that is called the spanning tree. So let's draw. This is a normal graph. Okay. So our spanning tree graph it should be like this. A, B, and we don't want cycle form. Okay. Then C. So draw this graph. Okay. So in normal graph we can add any path link, right? But in spanning tree we don't want cycle form. So this is our spanning tree, right? And you can draw in this manner also, like this also you can draw. uh just 1 minute. Okay. So in just you don't want to do what cycle from here. So if you, so this is our then only we can say this is a spanning tree. In normal graph you can form cycle, you can maintain like ABC. We have make a cycle, you can see in normal graph, but here we don't want cycle form here. So if we form the cycle, then we can't say that is a spanning tree. So this is our graph. Okay. So this is a graph of spanning tree. And what so we can define the spanning tree of a connected graph G, a subgraph of that contain all vertices. So this is a G and this is a spanning tree. So there are two formula algorithm for this problem. That is a Prim algorithm and Kruskal algorithm. Kruskal algorithm use the grid opportunity approach to find the minimum cost spanning tree. In this algorithm, all the edges of graph G are ordered in increased order of their weighted. At all the edges, one by one in increases order spanning, skipping those edges whose addition will create a cycle. Okay, so here add all edges one by one in increasing order, skipping those edges whose adding means who add the create a cycle. So, here in crucial algorithm. Okay, in next section we will see this diagram. Okay, through diagram we will check the crucial algorithm. Means here we have to remove the self loop, and what we want to do, we have to remove self loop here, and we want to skip we want to remove the cycle if suppose like this is there. Okay, and we want to convert in Spanish, so we have to remove cycle form. So we have to remove this link CA, right? So this is about your spanning tree. In next lecture we will see the what we will take the one example. So I said that crucial algorithm, right? So crucial algorithm, I said that algorithm use the greedy approach to find a minimum cost spanning tree. In this algorithm, all the edges of the graph G order in the increasing order of their weight, and all the edges one by one in increasing order, skipping those edges whose addition will create a cycle. Okay, then in Prim's algorithm here, the algorithm is used to find minimum spanning tree for connected weighted undirect graph. So Prim algorithm start by choosing an arbitrary vertex node of graph. At each step, new node will be added of to the tree. This algorithm stop when all nodes from the graphs are added to the tree. So यहाँ पे Prim algorithm जब all nodes tree को add हो जाएंगे तभी वो stop होता है. Okay, crucial tree में क्या होता है, वो cycle form नहीं होने देता. So ये किसका है, दिस इज अ फेमस एल्गोरिथम फॉर दिस प्रॉब्लम. सो हम लोग स्पैनिंग ट्री की टू फेमस एल्गोरिथम है, दैट इज अ Kruskal and Prim's algorithm. So this algorithm we will see in my next lecture. Okay, and then we will see the selection algorithm. So selection algorithm is nothing but a selection algorithm is a algorithm for finding the smallest large number in a list. Okay, this includes the finding minimum, maximum, and median limit. For finding the order statistics, there are multiple solutions which provide different complexity, and in this we will means those possibility we will see. Okay, maximum multiple. So then selection sorting. So selection sorting can convert to the sorting problem. To this method, we first sort the input element and then get the desired element. It's efficient if we want perform many selection. For example, let us say we want to get minimum element after sorting the input element. So we can simply return the first element assuming the array is short in ascending order. Now if we want to find the second smallest element, we can simply return the second element from the shortest list. That means for the second smallest element we are not performing the sorting against the same also the case subsequent queries. Okay. So we will see in next lecture the diagram and with example the both algorithm Kruskal and Prims. Okay, so today's lecture over here. Thank you. Okay, so आज के सेक्शन में हम लोग देखने वाले हैं प्रैक्टिकल ओके ऑफ एल्गोरिदम. So we already cover first practical okay in previous lecture only. So today we're going to see the three four practicals. So okay, let's start. For practical purpose we require Python, right? So in Python, you know how to download Python because you have studied in S.Y.C.S and S.Y.C.S also, right? So no need to explain the how to download Python, the how to save. You know the extension of Python is PI, right? So let's check the first practical. Let's open the practical here. Okay. So our first practical is which one? Short pie. Okay. This one our first practical opening. Okay. So here in it is a compression based algorithm in which each pair of adjacent element is compared and element are swapped if they are not in order. Okay, so sorting हमने last lecture में देखा ही है. So what is how to do sort, right? In spanning tree also we have sort the our particular element through the graph. Okay, हमने sorting की theory we have studied. So known to means अगर sorting की theory you know, then you can understand this practical here. So swap the element to arrange in order. So in short इस diagram इस practical का purpose है वो swap करता है element को arrange करने में in order में. Okay, so जैसे कि ये इन दिस ऑर्डर में है इसको जस्ट वो इन ऑर्डर में स्वैप करेगा. ओके, सो फॉर दैट वी रिक्वायर द फॉर लूप, देन enter a number in range. Okay, list -1 0 and -1. This is a binary number which we have studied in our tree, right? So this is the some coding, and this purpose of coding, that is it swap the elements to arrange in order. Okay, so when the above code is execute, it produces the following result. So let's run this code. Okay, then it will be swap in order. See what जो ये list दिया आपको 19 and whatever. So इसको इसमें क्या हुआ, ये अरेंज ऑर्डर में मतलब 2 6 11 19 इन ऑर्डर में एक ऑर्डर में ये अरेंज की गई. दिस इज द पर्पस ऑफ द फर्स्ट प्रैक्टिकल. सॉरी सेकंड प्रैक्टिकल, दैट इज बबल शॉर्ट इन अरेंजमेंट. सो अगर एग्जाम ऑफलाइन हो गया प्रैक्टिकल बेस होगा, देन आई विल you the PDF of this practical plus output. You just note down it and try to run by yourself. Okay, so this is the first practical here. So then second practical is about let's go. Second practical is about um, this one. Okay, okay, so here is a code for merge sort in a Python. Okay, merge sort. So this is the recursive approach for implementing merge sort. The steps needed to obtain the short array through this method can be found below. The list is divided into left and right. Okay, here list is divided into left and right. in each recursive call until two edges element are obtained. Now begin the sorting process. The I and j is iterator travels the two levels in each call. The k iterator travels the whole list and make change along the way. So यहाँ पे I J K iterators है. Okay. So यहाँ पे क्या इस practical का purpose क्या recursive call on each half, then two iterators of traveling in two levels Helvins and iterator for the main list, that is a k. So जो रेड में that is a command means इस कोड के थ्रू आपको ये कोड के थ्रू आपको इसके कमेंट्स के थ्रू आपको कोडिंग के मीनिंग भी समझ में आ रही है. Why we are using this one, why we are using this, right? So here what this is a recursive approach for implementing merge sort. The steps needed to obtain the sorted array through this method can be found below. Means here the list is divided into left and right in each recursive call until two adjacent elements are obtained. Now begin the sorting process. The I and j iterators traverse the two elements in each call. Okay, the k iterator travels the whole list. K iterator ये whole list में traveling होता है and make the changes along the way. If the value at I is smaller than the value at j, then left of I is assigned to the my list case sort and I is incremented. If not, then right j is chosen. This way the value being assigned through k are sorted. At the end of this loop, one of the elements may not have been traversed completely. Its value are simply assigned to the remaining slots in the list. And with that, merge sort has been implemented. So 3 represent the nodes connected by edge. It is non-linear data structure. You know the what is the meaning of non-linear data structure, right? You have to know this. It has the following properties, like one node is a marked as a root node, then you can say that each node can have what arbitrary nodes, number of child nodes. We create the three data structure in Python by using the concept node discussed earlier. We design it one node as root node and then more node as child node. Okay. So here let's run this program first. Okay, so this is your output. Okay, this again also arranged in order. Okay, merge short. जैसे कि हम लोगों ने पहले देखा था, this also arranged in order. In short, this is the purpose of program. Okay, then let's check the next practical, that is the binary. Okay, so let's see this. Okay, so यहाँ पे क्या हम देख सकते हैं, we just create a node class and add designer assign a value to the node. This becomes tree with only a root node. So here class node def int self data, then self dot left equal to none, then self right equal to none, self dot data equal to data. So here when the above code is executed, it produce following results. So it will be produce node 10 root, it will produce the root. Okay, so it is a short means this is the code about to produce the roots here 10. Okay, so then just 1 minute. Okay, so inserting. Okay, to insert into the tree we use the same node class created above and add an insert method to the insert method. Compare the value of the node to the parent node and decide to add it has left node or right node. Finally, the print tree method is used to print the tree. ओके सो यहाँ पे नोड और ट्री मतलब जो गिवन है वो पर्टिकुलर आपको प्रिंट होकर दिखेगी। व्हेन द कोड इज एग्जीक्यूट इट प्रोड्यूस द फॉलोइंग रिजल्ट लाइक मतलब ट्री किस फॉर्म में हमें रिप्रेजेंट करना है। ओके वो हम लोगों को ये ऑर्डर में शो होगा, जैसे कि सी हियर अभी यहाँ पे 12 6 14 दिया, लेकिन रूट पर्टिकुलर क्या है, इसका लिफ्ट क्या है, पेरेंट्स क्या है, वो इस प्रैक्टिकल का पर्पस है जो आपको आफ्टर रनिंग में समझेगा। ओके सी हियर सी मतलब यहाँ पे रूट 3 देन पेरेंट्स देन यू कैन से चाइल्ड अदरवाइज या both child otherwise one parent and one child, so it will show like this. Okay so this is about your nodes. Okay so compare the new value with parents node. Okay then next is smallest number in the 1 minute. Okay smallest number element. Okay so this is सो यहाँ पे पाइथन प्रोग्राम टू फाइंड द स्मॉलेस्ट नंबर इन द लिस्ट। तो हमें इस प्रोग्राम में क्या करना है, जस्ट स्मॉल नंबर हमें देखना है। गिवन लिस्ट नंबर द टास्क टू राइट पाइथन प्रोग्राम फाइंड द स्मॉलेस्ट नंबर इन द गिवन लिस्ट। सो दिस इज द जो कि हम लोगों ने स्पैनिंग ट्री में ही देखा था कि हम लोगों ने मिनिमम नंबर हर एक ग्राफ में से फाइंड किया था। प्रीवियस लेक्चर में ही हम लोगों ने वो देखा था राइट, कि हाउ या in upcoming lecture you will be see otherwise how to find means smallest number in स्पैनिंग ट्री थ्रू स्मॉलेस्ट नंबर हम लोगों को आइडेंटिफाई करना होता है और उसके थ्रू यू कैन बी अंडरस्टैंड। सो यहाँ पे जो भी स्मॉलेस्ट नंबर है वो हम लोगों को शो होगा यहाँ पे। ओके द पर्पस ऑफ दिस कोड। ओके सो यू विल गेट see this is the smallest number is a 4. Okay small so where it is a code, just a minute. Smallest number. Okay smallest. ओके सी इसमें 4 सबसे स्मॉल नंबर 4 है, सो हम लोगों को ये कोड के थ्रू स्मॉलेस्ट नंबर मिलेगा दैट इज द 4। ओके अगर जो बिकॉज 4 से मिनिमम कोई सा भी नंबर नहीं है। सो दिस इज द वी हैव डिड 5 6 प्रैक्टिकल हियर। ओके सो अगर थेरी समझ में आई आपको, थेरी अगर आपने अंडरस्टैंड किया तो प्रैक्टिकल में कुछ भी नहीं है समझने के लिए। ओके सो ओके थैंक यू।
एक मिनिट ओके आपलं प्रॅक्टिकल आणि हे झालंय आपलं. ओके सेकंड युनिट ऑलमोस्ट आपण कव्हर केलोय. ओके समजलं अब्दुल्ला, फैजान, प्रसाद?
जी मैम।
ओके चलो मीटिंग ओवर.